This video will be on homework 3, question 15. The question is asking us to prove that the limit of x as x approaches 3 of the function 1 over x is equal to 1 over 3. One way we could do this is simply state that this equation is a polynomial, and in a polynomial, the limit of as x approaches c will be f of c, therefore it will be 1 over 3. However, the question is asking us to use the definition of a limit in order to do this. So the definition of a limit is for a function f of x that is defined in an open interval about c, except possibly at c itself. The limit of f of x as x approaches c is the number L. If for every number epsilon more than 0 there exists a corresponding number delta is more than 0, such that for all x, 0 is between x minus c, and delta implies that f of x minus L is less than epsilon. So from the question that we are given here, we know that c will be as it approaches 3, therefore c is 3. We know that their f of x will be 1 over x, and we know their L is 1 over 3. So here are the values. L is 1 over 3, c is equal to 3, and f of x is 1 over x. So we're gonna, to prove the given limit statement, it is necessary to show that for all x between x minus 3 and delta and 0, then 1 over x minus 1 over 3 is less than epsilon. So the way that we do this is when we're given that the c is 3, so we simply plug 3 into the x minus c equation. In the other case, we know that f of x minus L is less than epsilon, and we know that our L is 1 over 3 and our f of x is 1 over x, therefore 1 over x minus 1 over 3 is less than epsilon. So we are simply plugging in values that we were given before. So now we're asked to solve the inequality 1 over x minus 1 over 3 is less than epsilon. Find an open interval about c equals 3 on which this inequality holds for x does not equal c. So we know that our equation is 1 over x minus 1 over 3 is less than epsilon. So in order to take the absolute value signs, we add a negative epsilon and a positive epsilon on each side. So now we're adding 1 over 3 over each side, and we put it x. We solve algebraically, and we're given that x is between 3 over 1 minus 3 epsilon and 3 over 1 plus 3 epsilon. So the inequality 1 over x minus 1 over 3 is less than epsilon holds for all x does not equals 3. In the upper interval, 3 over 1 plus 3 epsilon and 3 over 1 minus 3 epsilon, which were given before here. So now find a value of delta more than 0 that places a centered interval 3 minus d and 3 plus delta inside the interval of 3 over 1 plus 3 epsilon and 3 over 1 minus 3 epsilon. So take delta to be the distances from c to 3 to the near endpoint of 3, 1 plus 3 epsilon and 3 over 1 minus 3 epsilon. So we know that d will be the equal the minimum between these two distances, so 3 minus 3, 1 plus 3 epsilon, and 3 minus 3, 1 minus 3 epsilon, which would give us 9 epsilon over 1 plus 3 epsilon, and negative 9 epsilon plus 1 plus absolute value of negative 9 epsilon over 1 minus 3 epsilon. So given it is an absolute value, the number that we divide, in this case the biggest denominator, will give us the smallest value because we have an absolute value, so the negative values don't count. In this case, the minimum value that we would have is 9 epsilon over 1 plus 3 epsilon. So this will be LD given we were asked to place the smallest value of d that will be in the interval. Thus, if d has a value of 9 epsilon over 1 plus 3 epsilon or any smaller positive value, the inequality 0 is less than absolute value of x minus 3, which is less than delta. Automatically places x between 3 over 1 minus 3 epsilon and 3 over 1 minus 3 epsilon. So, to mark 1 over x minus 1 over 3 is less than epsilon. Since there exists such a value of delta, the limit as x approaches 3 of the function 1 over x is 1 over 3. And therefore, we have proven what we were asked in the beginning. Limit of x as x approaches c is 1 over x is 1 over 3.